All right, let's do the dependent samples t-test, the one you run when you have a within subjects design. Now, the cool thing about a within subjects design, or the different thing, it's still one row per participant, but each participant gives you two dependent variables. So I want to point something out. DV at tea, DV at coffee. Your dependent variables and your independent variables are mixed together in your columns in a within subjects design. So Brian is your participant. That's me. My energy in tea is very low. My energy in coffee is very high. I chose some of our fellow students to be in our experiment as well. And you can see that in the previous video as well. But ultimately, we have one row per participant. Each participant gives us two dependent variable measures. Each participant's in both conditions. So this column is Brian's dependent variable, Sarah's, Nori's, and Liliana's dependent variable when we have tea, and our dependent variable when we have coffee. Our dependent variable is energy. I could change my names of my columns if I wanted to, but I just want to show you the difference between a within subjects data entry and a between subjects data entry. This is a within subjects data entry, two DVs, two columns of data, right, that are mixed up at the independent variable level. It's really weird. It doesn't make as much sense as a between subjects data entry, but this is how you do it. Now, our analysis is the same thing, t-test. Now we use the paired samples t-test. I wish it said dependent samples. It doesn't. So dependent samples, paired samples within subjects are three words that all mean the same thing. We click that. Now we have it's asking for our paired variables. So it's asking for our two observations of our dependent variable. And so I throw them in there. Let's get everything I want. My students, my non-parametric, my effect size, my descriptive plots, and my descriptives. One of the things you're noticing, first thing we do, okay, we want to have this perfect interpretation of our Cohen's D's. This data is in line with our prediction. It's the exact same data as before. However, our effect size in our sample is negative. So we need to enter in our observations so that the effect size changes to positive. If you notice, it just did two t-tests, right? They're the same t-test. You can see them right here, okay? You can always do that if you want, and then just sort of pull out which one you don't want. So I just did that right there. I mean, it went a little fast. I didn't expect it to pull it out so quickly, but it did. Ultimately, I got my t statistic. I don't really care. My p-value is non-significant. I know nothing. My Cohen's d is large, but my population Cohen's d can be anything from negative less than small to positive large. I don't know much here. I know it's not an effect in the opposite direction from what I predicted, that is small, medium, or large, but still, I still don't know much here. I don't know the direction of the effect. I haven't disproven the null. I haven't supported the null. I don't know much here. I don't know, like, the population effect size could be in either direction. I need to run a better study ultimately. These are your descriptives. Now, the on average scores in the T group are more consistent than scores in the coffee group. I can see that from the standard deviation. But still, even with that violation of homogeneity, I am not seeing anything pop up in the non-parametric test. So ultimately, this is the same data as before within subjects design. We still know nothing, but that's how you do it. I think the most important thing here is make sure that when you run your t-test, that your effect size sign, okay, on this one right here matches, did this data follow your prediction? This data followed my prediction, my effect size sign should be positive. If the data do not follow my prediction, the effect size sign, we're going to re-enter it so that it is negative. No big deal. Easy peasy lemon squeezy. That's it. That's how we do it.